Howdy y'all. Welcome back to another exciting episode of Science with Mr. Jacobs. I'm Mr. Jacobs, this is Science, and today we are working on Bohr models. Yes, I know my attire looks a little bit goofy today. It's because today at school for us, it is PJ Day. If you feel like, as you're watching the movie, if you like what you see, if you feel like you learned something along the way, go ahead and smash that like button down below, and we'll go ahead and get after it. Bohr models. Bohr models were created as a way to show how many electrons are hanging out in an atom. Because if we know how many electrons they have, we can pretty much tell you how many protons and neutrons for the most part. Let's take carbon for example. Carbon's atomic number is 6. This 6 tells us a whole bunch about carbon. It lets us know that carbon has 6 protons, 6 neutrons, and those hang out in the nucleus, the center part of the atom. And then orbiting around them, in the electron cloud, we have 6 electrons. And those electrons are what we're going to be focusing in on for our Bohr model today. Every single atom that has more than 2 electrons, in its first electron shell, and that's what this circle that I just drew is called, it's called an electron shell. In the first level, that shell can hold up to 2 electrons. That is the most that it can hold at this first level. That it is full. That's all it can handle. And every atom, every element that we get past after hydrogen will have this first layer full. Now carbon though still has 4 other electrons hanging out. So that means that we need to draw another layer to this electron shell. And in carbon, because this is going to be our outermost layer, we're going to end up calling that our valence level electron shell. So since carbon has 4 more left, because 1, 2, 6 minus 2, 4, we need to add 4 more electrons to this shell. Now, this shell, although for carbon, is as full as it's going to get because carbon only has 6 electrons, this second ring can actually end up holding 8 electrons. So right now, carbon would be willing to accept 4 other electrons from other atoms, and when those atoms share those electrons, that's the bond that gets created that actually keeps those atoms together and forms those strong bonds that form the molecules. Now, let's step it up a notch so we can see if we can get out to a 3rd valence level. So I'm going to go ahead and get rid of this dude, and we're going to switch over to silicon. Silicon's atomic number is 14. So we need to draw our first layer, our first shell, and in that first shell we are able to put how many electrons back in there? 2. That first level is able to hold 2 electrons. That's standard across the board. Now we move out to our second layer. For carbon, this was our final valence level, but I don't think it's going to end up being our final layer for silicon. So if this layer can hold 8, said that for carbon, I got 14, I've used 2, which means I have 12 left. So if we go to put 8 in, 1, 2, 3, 4, 5, 6, 7, 8. I now have 10 electrons that we have drawn onto our silicon Bohr model. But 14 minus 10 is 4, which means that we got to go 1 more layer out. Now, this 3rd layer gets a little bit goofy. If we're talking about the transition metals, that's that middle group in the periodic table. Or if we're talking about the lanthanides and the antinnoids, those are like the 2 rows at the very, very bottom. Theirs can hold 18, and that's a little bit goofy because everything else, all of the others, can only hold 8. So since silicon is one of those on the outer sides, it's only going to hold 8 here. So we use 10 of them, we have 4 left, so in my valence level, this 3rd shell would end up having 4 electrons. Again, I hope you guys learned something. I hope this kind of helped you out with your Bohr models. As always, keep doing you. You got this.